Well, good morning, everybody. I'm Rebecca Chambers, and I am the R&D Manager for Mine Water Heat at the Mine and Remediation Authority. And today I'm going to be talking to you about our Mine Water Living Lab at Gateshead and the work that we've been doing recently. So just a quick introduction. It's the flagship part of our R&D programme, and it's a key component of our Mine Water Heat Opportunities Framework. And essentially what we want to look at is understand the interaction between operational mine water heat schemes at Gateshead, and then use the data that we generate and collect at our sites to make evidence-based decision making and therefore drive the wider uptake of mine water heat schemes. And one of the really interesting things about our Living Lab project, and something quite new for us, is that all of our monitoring data and data generated by this project will be open access and available on data.gov. So we had a couple of talks yesterday about the operational heat schemes, but essentially we are located in Gateshead, and between the Gateshead Energy Company scheme over here and our, and our Lanchester Wine schemes at Ness Road and Abbotsford Road over here. And essentially our Living Lab consists of 4 boreholes based over 2 sites. One's located at Gateshead Stadium and one is located by Bede Primary School. So I look at this in a conceptual section. So again, we have our GEC pumping operational scheme here. We have our Ness Road and Abbotsford Road here. And essentially we have our 2 boreholes split over 2 sites at Bede and Stadium. Now these are passive schemes. We don't do any operations here. This is purely to monitor any interactions and influences between the schemes and if we can see anything. And essentially in our 2 sites, we have a deep and a shallow borehole, and these essentially go into the same mine aquifer systems that are being utilised by the 2 operational schemes. So we've got the high mine aquifer, which is our shallower mine system, and we have our deep mine aquifer here. At Stadium, we managed to hit the Hutton seam, which has been used by the operational heat schemes. In Bede, we didn't quite make target and we're in the Brass Till seam. However, we know that this mine aquifer system is connected, and we've got some data that I'll show in a little bit that confirms that as well. So we're in a position where we can view any interactions with heat flow and water level data between these schemes. So what do our sites look at the surface? They're not very exciting. We say that they're a living lab, but essentially there's not much to see. Bede, we have below ground chambers, which basically do because we need to keep road access. And in Stadium, we have above ground chambers. And these are a lot better for us with respect to minimising flooding of our equipment. So what do we have in our boreholes? So for us at the Mine and Remediation Authority, they're the most highly instrumented boreholes that we have. All of our boreholes have level, temperature and conductivity loggers that are monitoring continuously, which we will periodically go down and download and then upload into data.gov. And in our deeper mine aquifer boreholes, so that is our Hutton borehole at Stadium and our Brass Till borehole at Bede, we also have fibre optic cables, thermistors and vibrating wire piezometers. And again, for us, this is really exciting because this is the first time that we've used fibre optics and VWPs in any of our boreholes. So in the interest of time, we're just going to have a quick look at water level data and what we can see. So this is water level from September of last year until February of this year. The red and the blue is our deeper mine aquifer system boreholes, and the yellow and the purple is our shallower. So the first thing that we can see is that the Brass Till is connected in our deep aquifer, which is what we expected, but it's showing the same response as our Hutton. So that's good. That gives us increased confidence that we are monitoring both the deep and the shallow at both sites. But the other really clear thing is that we're seeing influence of operations from both the Gateshead Energy Company and from Ness Road, so from Lanchester Wines. So for here, we can see a clear response from when Lanchester Wines were operating. And here we can see where the Gateshead Energy Company was operating. Something different from Gateshead Energy Company is that there's no set schedule when they're pumping. They essentially just turn on and off whenever they need the demand, whereas we can see that this was a turn on for pumping at Ness Road. Something that we can also see is that we're not seeing the same response in our shallower main aquifer system, showing that they are separate. So the water level changes in the deeper main aquifer are much greater. And something also to note is that we see tidal pressure responses in all of our sites. So we also done our first round of sampling that we undertook in February of March of this year. We done our standard suite of sampling such as organics and inorganics. We done dissolved gas concentrations, but we also wanted to do an extended suite and look at methane and CO2, gas stable isotopes, and collect some water for microbiology analysis. And essentially what we wanted to do with this is take as much information as we can. When the data comes back, we can then see what is useful, what is relevant, is it worth continuing to monitor as a baseline for the future. And we're also looking at headspace gas profiles within all four of our boreholes for methane and CO2. And we're currently waiting for the full analysis results from the lab to come back, but we've got some initial water chemistry results that we'll show you today. So there's two methods that we ended up using to collect our samples. We used a low flow bladder pump and we used a discrete interval sampler. And this was not our initial plan. We planned to go down with our bladder pump and essentially collect all of our samples from there. However, in reality, although our bladder should have been able to make depth with our drop tube that we brought down, we had a lot of issues with our tubings being stuck down the borehole. And that essentially meant that we had to regroup and go back down in March with a discrete sampler to be able to collect the depths, the samples from the deeper depths. But that then comes into another method comparison of a per sample versus a grab sample. Does it make a difference to the chemistry? And that's something that we're really looking at once we get our results back. When we went back down, we took a sample with our discrete sampler first, and then we done a bladder sample in our shallower wells. And essentially we want to compare of, does that make much of a difference to our chemistry? And if it does, that needs to future inform our next round of monitoring. And something else that we had to consider with the two sets of methods is the time required for each site. Obviously bladder pump flow compared to our discrete interval sampler, which we were getting 350 to 400 mils per sample run. That is an optimistic figure. I'm pretty sure we did not get that. So obviously the time needed to collect with microbiology, we need several litres at times for a sample set for that. And if you're going down to our deepest borehole, which is 182 metres, obviously there's a time consideration required when you're going and doing baseline sampling. So some initial water chemistry results that we have. So let's first look at our deeper main aquifer system. So this is in our Hutton and our Brass Till seams. And essentially this is the blue and the green markers on the Piper plot. We can see for cations, they're sodium and potassium dominated. For anions, we have bicarbonate type, and that overall we have a sodium bicarbonate and mixed type waters. When we compare this to our shallower main aquifer system, we can see that they do plot separately from our deeper aquifer, which is what we'd expect. So we're looking at the yellow and red markers on our Piper plot. But we can also see from, again, this is a limited data set as our first round of monitoring, and we'll be building up a better picture as we do continuous rounds, but that there is separation in where they plot between the bead high main and stadium high main as well. So bead high main shows for cations we have a no dominant type, where stadium high main plots in sodium and potassium. In our anions, again, bead high main, no dominant type, whereas again, stadium high main, we've got no dominant type or chloride type. And that really shows that with bead high main, we've got a mixed water type, whereas with stadium high main, we have sodium chloride type waters. And again, this is a limited data set. Hopefully, as we continue to go down and do further monitoring, we can build up this data set. So where do we see our Living Lab go for the rest of 2025? So let's a recap of what we've done so far. So we officially launched the Living Lab in January of this year. And soon after, we conducted geophysical surveys in all four of our boreholes. We've done our standard suite of tools such as CCTV, caliper, heat flow, density, but we also done BMR, so borehole magnetic resonance, which is something quite new for us. And the results of that should be coming out shortly as well. And then in February and March, like I said, we've done our first round of monitoring for our sampling. And as of today, we have an updated data package available on gov.uk. Coming soon, so our geophysics data and the factual report should be coming in the next couple of months, as well as our initial chemistry data being released. And in summer 2025, we should have a construction paper on our living lab coming out as well. And moving into the end of the year, so in autumn, we'll have our second round of monitoring, excuse me, and really taking the lessons learned from the first round and the comparison of our two methods, taking those lessons learned into our second round of monitoring in the autumn. And by the end of the year, we should hopefully have an initial paper out comparing the methods and the baseline sampling that we've taken. So things to look out for our upcoming data releases. Like I said, it is live today. We have updated water level, temperature and conductivity data from January to April of this year. All of our information and data is live at data.gov at this link here. We have our geophysical survey data and our factual report that should be due in June, followed up by our initial environmental baseline data. And in summer, we should have our construction paper out, which basically talks about our drilling of the living lab sites, but the lessons learned from our drilling from our first site to our second site, and what are the key takeaways of when we're drilling into mine workings. So in summary, our Gateshead Living Lab is a pioneering research facility. We look at thermal and hydrological behaviour and mine workings between these operational heat schemes. And the really cool thing for us is that all of our data is open access, so everybody can access it and use it to inform mine water heat schemes uptake in the future. So thank you all for your time, and that is my email address. If you want to get in touch with any questions, please do let me know.